Hi. In this video of Import, we are going to be discussing a very important question under rank criterion of consistency. I can call this an assignment video, but essentially this is a previous year question video. Yeah, let's see the type of question that has been asked. Okay, so the question is as follows. It asks you to find the value of neta. This is just a constant, but a fancier constant. It's a neta, for which the following system of equations is consistent and solve. First of all, I would like to point out that you have to understand that and solve implies that there are several other steps to this question. You can't simply stop at calculating the value of neta. You also have to talk about what the kind of solution is going to be when the value of neta is a particular value, right? Okay, now the way you proceed about this question is pretty similar to the way you were proceeding in questions when you were supposed to calculate rank in cases of unknowns, because essentially you write out the matrix, okay, and you see what the rank of A is, what the rank of A star is, and you comment on the type of system and the type of solution accordingly. Okay, so how would you do it? You would first have to write the augmented matrix, which I'm going to write here. Okay, so you have 111, 124, 111, 124, and I'm sorry, 1410. 1410. You have 111, 124, 1410, and 1 neta square. Yes. So 1 neta square. Okay. Now from this point forward, they are going to look like n's, but let's just pretend it's a neta. Okay. So the first thing I will do is R2 goes to R2 minus R1, and you would have R3 goes to R3 minus R1 because I want to make these two zeros. Okay, because these are two different rows, I can carry them on in one step. Otherwise, it is not possible to do. So please be careful when you do engage in this practice. 1 minus 1 is 0, 2 minus 1 is 1, 4 minus 1 is 3. 1 minus 1 is 0, 4 minus 1 is 3, 10 minus 1 is 9. Neta minus 1 is neta minus 1, neta square minus 1. Okay. Now R3 can go to R3 minus 3R2. So you would have something like, yes, 1, 1, 1, 1 neta minus 1, 0, 1, 3 as it is, and you have 0 minus 0 is 0, 3 minus 3 is 0, 9 minus 9 is also 0, and you have neta square minus 1 minus 3 into neta minus 1. Okay, so I can write this a little more clearly here, but you essentially have this matrix. So you have 1, 1, 1, 0, 1, 3, 0, 0, 0, 1 neta minus 1, and neta square minus 1 minus 3 into neta minus 1. Yeah, so this is the matrix that you have. Okay, here are some of the things that you should be able to understand looking at this matrix. One is that you finally have it to an upper triangular form. Okay. So ideally, you should now be able to open it up and calculate the values of neta. But before doing that, the question asks you to comment on consistency. Okay. What was the main criteria under consistency? Rank of A and rank of A star. In this case, this is the A matrix, right? You can see that rank of A is definitely not equal to 3. Why? Because the determinant of A is 0, because it has a row of zeros, yes? So this row of zeros right here implies that rank of A is less than 3, okay? And this particular minor right here, if you look at it, 1 minus 0, implies that rank of A is actually equal to 2, because a 2 cross 2 minor is non-zero. Okay, so you know that rank of A is equal to 2. Now for A star, the maximum rank that A star can have is once again a 3, right? But to ensure that the rank is actually not 3 but 2, or rather to ensure that the system is consistent, what you will need is that this number right here, neta square minus 1 minus 3 neta minus 1, should be equal to 0 for it to be a consistent system. Another way to see this is that if you were to open the system of equations up, if 0 plus 0 plus 0 is not equal to 0, then this would be an inconsistent system, right? So 0 plus 0, I mean, I'm hope this is, very clear. I will also change colors to, sort of make my point a little more colorful. Okay. So, what I'm saying is that if you were to open the system up and you would have something like 0 plus 0 plus 0 as the last equation is equal to something which is, let's say any positive number, okay, then this would be an inconsistent system, right? Which implies that for consistency, neta square minus 1 minus 3 neta plus 3 minus 3 neta plus 3, yes, should be equal to 0. Okay. Which means that neta square minus 3 neta plus 3 minus 1, which is plus 2, should be equal to 0. So neta square minus 2n, neta square minus 2 neta minus neta plus 2 should be equal to 0. Which implies that neta square, so neta into neta minus 2 minus 1 into neta minus 2 should be equal to 0. So if I were to erase some portion of the ink here, um, okay. So from this, what you have is that neta should minus 1 into neta minus 2 should be equal to 0 for consistency. So neta is equal to 1 or neta equals 2. Okay. What you now do is put these real values, because like I had said, the question also asks you to solve. What you do is you put these values back into the matrix that you had earlier or into the reduced form of it, and then you see what is happening and what is the solution. Okay. So I'm just going to use neta equals to 1 for now. Okay. And I'm going to substitute it. Again, let me use the eraser to erase all of this. So this brings you to the final part of the solution for this question. Okay. So if you were to substitute neta back into the matrix, what would you get? You would have 1 1 1 1. Okay, and you would have 0 1 3 neta minus 1, which is going to be 0. Okay, and you have 0 0 0 and neta square minus 1, which is 1 minus 1 minus 3 into 1 minus 1, which is 0. So this, right? So you would have something like x plus y plus z is equal to 1, and y plus 3z is equal to 0, which implies y is equal to minus 3z. Okay, so because y is equal to minus 3z, you would have something like x minus 3z plus z is equal to 1. So x minus 2z is equal to 1. X is equal to 1 plus 2z. Okay. So again, let z be any arbitrary number k. So z is equal to k, y is equal to minus 3k. Okay. And x equals 1 plus 2k. And this is the solution for this particular system. Okay. Again, if you put the value of neta equal to 2, you can calculate it in a similar manner. The solution in that case is also going to be exactly the same, which is what you have right here. Z is k, y is equal to minus 3k, and x is equal to 1 plus 2k. So I actually solve it for neta equal to 1 in this case also. You can solve it for neta equal to 2. You should get the exact same solution. And, that's it. Thank you.